This is BMAT 2021, Section 2, Question 25. Here we have a family tree showing different individuals for a recessive condition. If the box is shaded in, they are affected, so we have 2 affected males here, and everyone else is unaffected. And we have a few statements, we need to work out which ones are correct. So first of all, we have to work out if individuals 1 and 2 are both heterozygous. So let's consult our diagram. What do we know about 1 and 2? Well, we know they're unaffected, so that could be heterozygous or homozygous dominant. And we know their offspring, one of their offspring is affected. The only possible genotype for this affected offspring, because it's a recessive condition, is going to be homozygous recessive. So I'm just going to indicate that with 2 lowercase a's. And for that to be the case, it must have inherited 2 recessive alleles, 1 from each parent. Therefore, each parent must have 1 recessive allele in order to produce its offspring. So we can draw that on there. And we know that they're both unaffected, therefore they must also have at least 1 dominant allele. So they must have 1 dominant and 1 recessive to produce an affected child and be unaffected themselves. So they're going to look like this. So they must be heterozygous. So we can tick this one off. There we go. Our second statement is that individuals 3 and 4 are both heterozygous. So what do we know about these? We know that their father has 2 recessive alleles. Therefore, the only one that it can pass down is going to be a recessive allele. So it must inherit 1 recessive allele from the father. So we'll write that on there. They both have 1 recessive. What else do we know about them? Well, we know that they're both unaffected, so they must have at least 1 dominant allele to be unaffected. So that's going to look like this. And again, they're going to be both heterozygous, so we can tick this one off as well. Our final statement is that individuals 5 and 6 have a 50% chance of being heterozygous. So here are our individuals 5 and 6. Well, to know what their genotype is, we need to know something about their parents. So what are their parents like? Well, we can see that they're in exactly the same situation as 1 and 2. They're both unaffected and they have 1 child that is affected. So this child must have the genotype AA, and so the parents must be heterozygous themselves. So now we can work out the percentage chance that these 2 are heterozygous by doing a dot and cross diagram. So if we set it up, it'll look something like this. So we're going to cross these 2 heterozygous parents. So take a second to fill out this table and see what the percentage is. So our completed table will look like this. We can get rid of this box here because we know that these are both unaffected individuals, and our homozygous recessive means they will be affected, so we can just not include that. And you can see our 2 heterozygotes there. So overall, that's a fraction of 2 out of 3 is the chance of them being heterozygous, or 66%, which is not 50%. So this is incorrect. So only 1 and 2 are correct, and our final answer is answer E.